On this page, we're going to go back and just do some final practice solving quadratics. Now, this section says express your answers in simplest a plus bi form, so I do know that all of these answers are going to be complex answers. For my first one, I don't have the equation equal to 0, but I see it's quadratic from the 2x squared, so I'm going to move over the 7x and the 10 to the other side of the equation so it does equal 0. So I get 2x squared minus 10x plus 40, that's a plus 10, I know it's hard to see right here, equals 0. Now, I see that I could factor out a 2, but the factoring is not going to take me anywhere, especially since the problem says simplest a plus bi form. I know that the quadratic is not factorable, so I'm going to go straight to the quadratic formula. So I have negative 10 plus or minus the square root of negative 10 squared minus 4 times 2 times 40. I'm going to be doing these pretty quickly because we've done a lot of practice with the quadratic formula. So, sorry, let me just put that down, 2 times 2. So I'm going to just write down what it would be if we typed the discriminant in your calculator. So this number here evaluates to negative 220. So I have 10 plus or minus the square root of negative 220 over 4. The biggest perfect square that goes into 220 is 4. So I'm going to break that radical up into square root of negative 4 times the square root of 55. Then when I rewrite this, I have 10 plus or minus 2i radical 55, because I simplified the square root of negative 4, over 4. Now, this is going to add something little about a plus bi form. Because we want the real part and the imaginary part separate, when I want a plus bi form, I'm actually going to split this up into 2 separate fractions. So here, I rewrite this as 10 over 4 plus or minus 2 radical 55 over 4i. So that looks kind of weird. We don't usually split it up, but once again, that's a plus bi directions. And I want to take this term and put all the real parts together for the b. So 2 radical 55 over 4, and then the I comes second. We individually reduce the fractions at this point. So my final answer is 5 halves plus or minus radical 55 over 2i. As I said, that's a separate type of simplification that we used for that a plus bi form. We don't split up if there was no I there and it didn't give me that directions. I wouldn't split it up into those 2 parts. The next one, I actually can avoid the quadratic formula because this is an incomplete quadratic, right? There's no x term, so I can just subtract the 25 on both sides. I get 16x squared equals negative 25. Divide by 16, and I get x squared equals negative 5/4. So I can already tell when I take the square root of both sides that I'm going to have imaginary answers. So I get x equals, don't forget your plus or minus. Basically, we have the square root of 5 on the top over 2, and then the I is going to go at the end for that a plus bi form. So in this particular problem, we really don't have an a. The a is 0, so we can just leave the answer like that. On either of these first 2 problems, I can split it up into 2 answers and write it in that roster notation. Moving down the page, I'm just going to erase this solution so we have a little more room. The next one, we see we need the quadratic formula again because it does have an x term. So I have x equals negative 7 plus or minus the square root of negative 7 squared minus 4 times 1 times 20 all over 2 times 1. That gives me 7 plus or minus, and here's the square root, and that discriminant is negative 31. So this one, when I break it up, or I start to simplify this radical, I do have to write I radical 31, but the 31 does not break up. When I put it in a plus b form, that's going to be 7/2 plus or minus. The real part is radical 31 over 2, and then the I goes at the end. I am going to write this one in the roster notation just so you can see how it would look, even though we've seen similar things like this before. So we have 7/2 minus radical 31 over 2i and 7/2 plus radical 31 over 2i. For my last one, this one I need to set it equal to 0. I get 2x squared, so 4 here, plus 6x, sorry if you can hear the lawnmower outside my house, plus 11 equals 0. Now, we haven't done this on the other ones, but just quickly checking, if I look and I think about b squared, that would be 6 squared is 36, and I compare that to 4 times 2 times 11, that's 88, right? I can tell that we're going to have imaginary roots. So I know that even though the problem already told it to me, I could figure that out on my own. Quadratic formula, because we have all three parts, right? Or we have a b term is the big deal. Negative 6 plus or minus 6 squared minus 4 times 2 times 11 all over 2 times 2. This is going to give me negative 6 plus or minus the square root of negative 52 over 4. So I have negative 6 plus or minus, this is going to be square root of negative 4 times the square root of 13 over 4. So we have negative 6 plus or minus 2i radical 13 over 4. And this is going to reduce to, or split up first, right? We're going to split up. We have negative 6 over 4 plus or minus 2 radical 13 over 4i, and reduces to negative 3/2 plus or minus 1 radical 13, or just radical 13 over 2i when I reduce the fraction here and I reduce the fraction here. Now, it's possible if you go back to the first page of this lesson where that denominator goes away. So we have kind of that more normal looking a plus bi form where there's no fractions, but we can have a plus bi form with fractions as we saw in a bunch of these problems.